Let us now solve question number 21. So it says there is a tray which is suspended through two springs in parallel. Each spring has a spring constant K, and the value of K is not mentioned, okay, just K. Now the tray has a mass of 10 kg, which is mentioned here. When the tray is depressed a little and released, it executes simple harmonic motion with a period of 1.5 seconds. So period is 1.5 seconds. When a block of mass small m, this is small m, is placed on the tray, the period of oscillation becomes 3 seconds. Okay, so when there is only tray, that time the period is 1.5 seconds. When block is put here, the period becomes, let us call this T1, then T2 is given to be 3 seconds. The value of this mass of this block which they have placed here, they are asking. So let us solve this. So now these are two springs in parallel. So effective spring constant in parallel is K1 plus K2. Since both are K, it will be twice of K. Okay. So initial time period will be 2 pi root over, only the tray was oscillating. So mass of the tray divided by 2K. After you put small mass, the time period becomes 3 seconds. So let us call this T2. So it will be 2 pi root over mass that is oscillating is m plus m by same spring constant, so 2k. Right? If you divide these two, you will get T1 by T2 equals, everything will get cancelled except here numerator mass of the tray, here mass of the tray plus mass of the block. Now T1 is 1.5, this is 1.5, this is 3, so ratio will be 1 by 2, right? If you square it, it will become 1 by 4 equals to m by m plus small m. Cross multiply and solve, so 4m will be m plus small m, so small m will be 3 times capital M. Capital M was 1.5, so 1.5 into 3 will be 4.5 kg. So it is a straightforward question, nothing much to worry. 4.5. Okay, so the correct option would be 4.5 is not mentioned here. So let us check once. So when the tray is oscillating, time period is 2 pi by root over mass of the tray divided by, mass of the tray is given 10. So this is 10. So 10 times 3 will be 20 kg. Okay. So option C. So this is an example where if you don't look at the values which are given properly, you will be wasting time, as I did now. Okay. So let us now solve question number 22. So what does the question say? It says, question number 22 says, a simple pendulum, so now problems are based on pendulum. A simple pendulum has a period of 3 seconds. 3 seconds. You know the formula, right? So you can mention 2 pi root over L by G. If the point of suspension of the pendulum starts moving upward with velocity v equals to kt, where k is 4.4, some constant, the new period will be how much? So this is 4.4. Okay, it may look like 44. So 4.4. Now, why will, so here is the pendulum. When it is oscillating, this is the time period. Now, this point of suspension is moving up with some velocity. Why will the period be affected? So you can consider this whole thing is in a lift, right? So if the lift has acceleration upward, then inside the frame of this lift, there will be a pseudo force ma downwards. So the effective gravity will be mg, which is already there, plus ma. From ground frame, the acceleration of this lift is upward. So from the frame of the lift, you will feel a pseudo force downward, right? So this would be the net pseudo gravity. Okay. So the effective acceleration due to gravity will be g plus a. So is there any acceleration? Yes, because velocity is changing linearly with time. Acceleration is rate of change of velocity, instantaneous acceleration dv by dt. So that will be simply 4.4. So initial period was 3 seconds. So the new period will be 2 pi root over, length is remains the same, g will be replaced by g plus a. So take the ratio t dash by t, is visible? Yes. T dash by t, that will be equal to root over, t dash has g plus a in the denominator, t has in the numerator. Now the values of g plus g, you know, a is given, is a, we have found 4.4. So you can substitute and calculate. Okay. Let's see the next question now. Question number 23. So 23 is about a pendulum which is oscillating in some liquid. So there also what happens is, because of buoyancy, the effective gravity will be changed. Okay. So in air, when a pendulum oscillates in air, whose density we can neglect. So actually it should be in vacuum. When it oscillates, the period is 2 pi root over L by J. In medium, if it oscillates in some medium, so it is a medium whose density is rho, then you know that here, when it is in air or vacuum, the tension is balanced by the mg in equilibrium. Okay, and the force which balances the tension, that is mg, divided by m, that gives you the effective gravity, which in this case is g. Here, when there is fluid, besides tension, there will be also a buoyant force plus buoyant force, and together they will balance mg. So the effective, not effective, the tension now will be basically mg minus buoyant force. Now in terms of densities, if you write mass of the block, you can write density of block or body into volume into g. Buoyant force is weight of the fluid displaced. So density of liquid, volume of liquid displaced in this case will be same as volume of the bob, because the entire bob is inside the medium, into g. So that would be your tension. So rho b minus rho l times Vj. So that would be the tension now. Before the tension was simply mg. So you divide this by m, you get the acceleration or the effective gravity. Here if you divide by m, your effective gravity will be rho b minus rho l Vg. Because for example, why am I calling this tension as effective gravity? See, if you put a scale here, okay, then that scale will measure the tension, and that is what we call as apparent weight, or you know, the feeling that gravity gives you. So when you are left free in vacuum or in air, let's say, neglecting the buoyancy of air, that time you don't feel your weight, though your mass is still there. Why? Because there is no support. So here, so whatever force is balancing the downward force, that is what gives you the feeling of gravity. So in case of, if you are standing in a weighing scale, then normal force gives you that feeling, right? So in the case of a wire and all, the tension gives you that feeling, and that is what is measured by weighing scales or spring balance. Okay. So divide this by mass. Okay. So G effective will be density of body minus density of liquid into Vg by density of mass of the body. I can write in terms of density of body into volume. So volume will cancel. This will be 1 minus rho L by rho B into G. So that will be the G effective, which should be mentioned now in the formula for time period of pendulum. So 2 pi root over L by this G effective. So when a pendulum oscillates in a medium whose density is not negligible, you must use this formula. Now here the density of the material of the bob is given 4 by 3 times 1000. So this is 4 by 3000, and the liquid is water in this case, so density of the liquid will be 1000. So if you put 4 by 3 here, it will become 1 minus 3 by 4, right? So this quantity will be 1 minus 3 by 4 into g. So this will be 2 by root over 1 minus 3 by 4 will be what? 1 by 4. So there will be 4L by g. Now initially they have mentioned that the period of the pendulum is t naught. So this is actually small t naught initially. So root 4 is 2. Remaining thing what is left? 2 pi root over L by g, that is t naught. So the answer is twice of t naught. Option C.